Hello. Thank you for joining us for ShipIt number 14, How We Write React Native Apps at Shopify. ShipIt is our monthly virtual gathering where we bring together engineering Shopify folk to talk about the things we're working on and take questions from you that decide to join us today. ShipIt was a way for us to keep connected with you in this digital world. My name's Anita Clark. I'm the Senior Managing Editor at Shopify, and I run the engineering blog. Today, we're talking about how we write React Native apps at Shopify. We're here with the developers that are setting the React Native standards at Shopify, and they'll share more about how we write performant React Native apps. We're taking questions at the end of their presentation, so please use the Q&A mode in the chat to ask, and we'll get to it. Great, let's get on with the presentation, and thank you all for being here with us today.
Hi, everybody. I'm Colin Gray. I'll be presenting a little bit later. I wanted to introduce our first speaker, Haris Mahmood, and kick it off, Haris.
Thanks, Colin. Hi, folks. My name's Haris. I'm a senior engineer at Shopify, currently working on the Shop app. Shop is a mobile app that helps you keep track of your packages and discover and rediscover shops and products across the Shopify ecosystem. So today I want to firstly chat about UI development, styles, and theming, and sort of some high-level principles that we like to follow regarding these topics at Shopify. So even before we get to writing any code, the first thing that we really like to focus on is building a strong relationship between client developers, folks writing React Native, and designers. This isn't particular just to React Native projects. This is a Shopify-wide thing where all developers like to maintain a very good relationship with their design counterparts. This results in the ability to give and receive feedback often and super early on in the process. This has helped numerous times to save time in the long run, to build a really, really tight feedback loop that results in a really high quality product much sooner and reduces the overall number of complexities and issues and surfaces those earlier on. Something else that we like to do is build comfort in each other's systems. And what I mean by that is, as developers, we like to familiarize ourselves with Figma and any other design tool that our designers like to use, to be able to give feedback in those tools, to be able to easily navigate between the different artboards and projects, so we're able to talk to them where they work. Similarly, the design folks will take the time to have development builds for the various apps on their devices, or at least have nightly builds set up on their phones so they can look at work in progress features and give developers feedback early on about how something is behaving or not behaving. This results in a really, really cohesive team environment and builds a really strong relationship with both sides, resulting in super, super high quality projects right off the bat. The other major design principle, or one of the biggest design principles that we work with, is the idea to lean into the platform. So the Shop app, for example, is on iOS and on Android, and the point of sale app recently just launched for Android. One of the things that we like to do is not fight the platform defaults or their specific platform UX and behavior that our users are expecting and have come to understand. So for example, when it comes to typography, we do have some custom branded typography as well, but a lot of the typeface work that is used on iOS relies on the SF Pro font for the Shop app, and also the Roboto font for Android. Similarly, when building on the Android side, we like to adhere to the material design patterns and everything else that comes along there. And we lean into the navigation patterns for the tab bars, for the headers, and anything associated with that, both for iOS and Android. This does result in our apps looking slightly different from one another based on those two platforms, but it results in our users, who we're building this for in the first place, find themselves be able to navigate the app and understand it better just right off the bat without additional cognitive load And it also reduces the amount of effort that we need to put in as developers to create these patterns ourselves and then maintain them and resolve any issues that come about. Just leaning into these things that both the iOS platform and the Android platform has been doing and has done for the longest time allows us to focus our efforts on the core features that we're providing rather than fighting and trying to create a consistent navigation behavior across those platforms. Similarly, when it comes to tap states, for example, Android has the ripple effects that sort of sits within the material design ecosystem. We like to make sure that we maintain those behaviors as well for those respective platforms. And buttons and tap states and touchables feel very much native based on the platform that you're experiencing them on. The other really big principle that we really lean into is building and enforcing design systems. Design systems allow us to move super quickly once they've been established. They allow us to maintain consistency across a wide range of projects within the company. And one of the biggest and crucial things for Shopify is the ability for them to support a large number of teams and teams of large sizes. Polaris, for example, is one of the most popular ones that you may have heard about already. Polaris is Shopify's go-to design system for all things merchant-facing. It talks about color, talks about components, talks about voice and tone, and things beyond just the UI. It's super well done. It's been maintained for the longest time. Now, just because we already had a well-established design system doesn't mean that we're forced to use that for every single project that comes about. The design system itself isn't crucial. It's the concept of a design system that we like to enforce. So the Shop app itself has its own design system that's very unique and very different from the Polaris design system. But we like to make sure that we continuously evolve the design system itself and make sure that all aspects of our app are up to date and continuously following the design system's best practices. Similarly, the point of sale app utilizes the Polaris retail flavor design system, and this is something that they're continuing to work on as well. Out of all the libraries and features that we use, the most crucial and the one that has made the biggest difference in how we work on UI at Shopify for React Native projects is the restyle library. This is available this is open source and publicly available, so I highly recommend checking this out on GitHub. Restyle is a type enforced system that helps you build UI components. It has a very similar vibe to styled components with a unique flavor of its own that allows you to rapidly prototype and build foundational components across your app. It alleviates the pressure and the needs to use the style sheet API that React Native provides out of the box. It also makes it really easy to build a set of palettes and build themes based off of those palettes. So the concept of themability is baked right into Restyle, and you get it as soon as you have Restyle set up. So dark mode, for example, became super popular, and this is something that both the point of sale app and shop supports. And this has been, we were able to manage this with very little effort using the Restyle library. Restyle also supports breakpoint. So yes, even though Shop is just for mobile apps, the sizes of mobile devices has changed drastically. We've got super small ones to super large ones, skinny ones, thicker ones. And so the Restyle library also helps accommodate a variety of those different device sizes using Restyle's own breakpoint configuration. Utilizing the theming concept from Restyle really helps further enforce our design system and maintain consistency. All the components that we either create or use that have been predefined already are all built using Restyle, which itself utilizes our palettes and themes, which themselves are built on top of or utilize the design system that the Shop design team has put together. So this results in a super smooth experience, resulting in super high quality designs built off of and influenced by the design system. If you haven't had a chance to check it out already, I highly recommend you do so. All right, so next up, I'm going to pass it off to Gil to chat about testing.
Thanks, Harris. Hi, I'm Gil. I'm one of the developers working on the Shopify new point of sale app, which has just been released for Android, by the way. And today I'm here to talk about testing and how we're approaching it when building React Native apps at Shopify. First of all, let's talk about why we write tests. Building things is generally hard. It's a complicated craft that usually requires a lot of effort. And as a very complex initiative, we want to build safeguards that will help keep us things up and running. Testing is one of those things. However, there's a catch. Writing tests sometimes can feel very unproductive. And to help fight that, we have started to focus our efforts to get the best results out of it. As you might know, tests are usually classified in 3 categories: unit, integration, and end-to-end. That's widely known, but I've added a 4th one that I believe is worth mentioning, which is a static analysis, because that also helps you avoid making mistakes when you're writing code. If you go from top down, you notice that there is a cost and impact relationship there, where tests with the most impact are usually the most expensive ones to write and run. And this is something to be mindful of. With that in mind, we also have to be mindful that testing is a finite investment. It requires time and money because you have actual developers working on it. So you have to be mindful that you're actually allocating resources on that. Also, when you write tests, there will be a threshold where the tests will start to provide diminishing returns. They'll naturally overlap with each other, which will make you test the same thing over and over, and they'll just start providing less value. And because of that, prioritization is really the key to avoid waste. And from that cost-benefit analysis, one could quickly say, oh, you should write tons of unit testing. They're pretty cheap, and they'll give you 100% coverage. Like, they cost the least, so it's a no-brainer. Well, while I don't entirely disagree that unit tests are very effective in what they're designed to do, that approach has one big problem for me. Your system is built as a set of features, all working together, and unit tests might not be the best representation of that. I love unit testing. Please don't give me hate for that. I write a lot of them, but one of the first things that we learned along the way was that you should actually testing as close as how they're actually used in your app. We have 2 options to do that, as I said, integration tests and end-to-end tests. We have decided to use integration tests because the cost benefit of them are actually higher in our experience, and they're not as flaky as end-to-end testing. Another big learning that we had was that if you're not really sure what to test, you should think about how a user interact with your system, right? You should basically write tests. You should strive to mimic the behavior of the user when you're writing the test. So if a user can interact with the button and they expect to see a given copy on the screen, you should probably write a test for that. If you approach testing from a user's standpoint, you're actually going to realize that your test will start to provide more and more value because you're actually writing tests to assess what a user would do in your system. Another big learning was only mock what's absolutely necessary. The more you mock your system, the more likely you are to test your mocks and not your system. So we usually recommend people just to mock any native modules, because you have to mock that because we usually run an integration test in Jest, and that cannot execute native modules. So we usually write mocks for those. And for any network requests, so you have a REST API or a GraphQL API, we usually mock those to avoid having any network issues that will make our test to become flaky. So those are usually our 2 recommendations for mocking. And it's the bare minimum. So like your system should be tested as is, because that will like approximate your test from your actual usage. Another thing that it might be a little contentious is that we do not encourage you using snapshot testing. And that's for a couple of reasons. Their output form is just not readable enough, and they constantly break. You're going to notice they break like every small change that you make in your system might actually break like tons of similarly unrelated tests. So they'll end up become just white noise. People will stop paying attention to them, and they'll just not provide value anymore. As an alternative, we actually use Storybook to document our components and trust that we have enough people interacting with them to detect any significant regressions. Colin will touch a little bit more on Storybook later. Lastly, developers should be actively engaged in this discussion. This is a team effort. Like, we're all trying to achieve the same goal, moving fast and not breaking things. So everyone is actually interested in the same thing. So this should be a team-wide conversation. I'll leave you with a list of tools that we use to write our tests. This is a pretty standard set. There's nothing new and fancy here. The couple of things that you might notice that are actually different is that we use two Shopify-specific libraries. They're all open source projects, so you can actually check their documentation. They're all on GitHub. I definitely recommend you do. But we have our own flavors for our renderer, which is quite similar to a React testing library, which is I think is the most popular one. And we do have a GraphQL testing library as well, which helps mock our GraphQL endpoints. So this helps us to become more productive when writing tests. Again, they're all open source. Definitely recommend checking out. And I'll pass it off to my wonderful POS colleague, Michelle, to talk about working with native SDKs. Take it off, Michelle.
Thanks, Gil. Hey, everyone. So Michelle here from also the point of sale team at Shopify. I've been working on the point of sale team ever since we made that bet to go all in with React Native. And as Gil mentioned, we had just released it. So check that out if you have the time. What I wanted to talk today about is working with native SDKs. So in our point of sale app, we have integrations with card readers, printers, barcode scanners, cash drawers, and things like those, where we do use the native SDKs for them. So in some cases, your app may not even need to use native SDKs or create something called a native bridging module, because you may just be able to use everything that comes with the React and the React Native package. But let's focus on the native SDKs here and how we use them, and also when do we want to create them. It's not a normal part of your React Native process, app creation process, but when you do want to use them, you will be able to have access to, say, like the location services, the camera, the sensors, the canvases, anything in that native layer that you might not be able to use or packages out there may not be able to provide for you. When there are platform-specific implementations, such as, say, background or foreground services or push notifications, you may then need to create individual bridging modules for, say, iOS or Android. Another case is when you already have a native app and you are experimenting with making that into a React Native app. So you have existing SDKs in them. You can still use you can still create a native bridging module to use those existing SDKs. The last point that I wanted to talk about here was if there are packages that provide what you want, but you find they are too bloated, you just need a small snippet of that code to do something in your app. You might not need to include that whole package. You can then create your own implementation that has the iOS and Android equivalent. So how do we use native modules in point of sale? We have had internally created SDKs for our checkout process and for our hardware pieces that we use in our previous app. So our previous point of sale app was an Android native app. The new one is a React Native app. We have had existing SDKs for them, which we have then used in our React Native app with success. There are also third-party SDKs that your company or yourself may not have created, but is available for you to use. You can then use that SDK to also integrate it into your app to use that feature. There is also a feature in the point of sale app where we accept credit card payments, and there is sometimes it may still need a signature. So you can also create a custom view manager to accept those signatures and have it view smoothly, and your user will be able to tap or swipe through your device and have that be smooth as it gets accepted by the app and the point of sale device. The image that I have here at the bottom is actually an example. It's a screenshot from our point of sale app where we needed to know if the Bluetooth of the device was connected or enabled or disabled, because our card readers and some of our other hardware use Bluetooth connectivity. So we had found a package where it allowed us to get the connectivity of many other things for your tablet or for your phone. But in the end, we were like, we don't need everything else. We're just really concerned if Bluetooth is enabled or not. So at this point, it's like, you don't need to add that whole package. You can kind of create your own implementation that works for the Android platform and one that works for the iOS platform. And here you also reduce your package size and your app size. This here is a little gallery of what we have in our point of sale app. We have card readers, and we have some printers and barcode scanners and cash drawers. So for our card readers, we have an existing SDK for them that talks to our checkout process and our card readers and the SDK built into that. And we have written them in Kotlin and have used that in our native we have created native bridging modules for those, so we can use them in our React Native app. So now you know that you can use them. How do you actually exchange the data? So if you have a card reader, how do you process that card reader payment when you tap on it, and then you accept it, and then you also want to display some kind of UI update? So there are 3 different methods that you can use to exchange data. So there are promises, callbacks, and event emitters. It usually depends on what the method that you want to use. So for our checkout process, which is, say you tap a product on your device, it gets added to cart, and then you see kind of a subtotal. So in this process, we talk to the servers. We have a checkout SDK, a native one. It talks to our servers. It gives us the line item prices, the shipping prices, the tax prices. And with this, we rely on promises to give us this information and data back right away so that we can update the UI. On the other hand, for our hardware features, such as, say, when we want to print a receipt or when we want to open a cash drawer or scan a barcode, in this we use event emitters. So for, say, printing a receipt, you can press a button, you call your native module and the native function in that to print it out, and then you can then emit a message back as to when that process is finished. And you can also update your data to maybe enable the button again so that your user can press it. Similar to the barcode scanner, once we press the scanner to scan a barcode, we can then emit a message saying, oh, this is the data that came back to us from the SDK, send that back through the bridge, and then do whatever we want with that in the UI. The last point that I wanted to bring up here was actually Kotlin multiplatform. So this will allow us to create kind of like one code base that will talk to iOS and for Android. And I'm actually going to pass it over to my colleague, Colin, who has written a blog post about this. And we'll talk to you more about Kotlin multiplatform.
Great. Thank you, Michelle. So we had an issue with the app for a while where we had background jobs that were running. They would fetch data from the network and then write that to a database. And we found that while those jobs were running, they were all CPU bound and they would impact the performance of the app. These were all written in JavaScript. So we decided that we were going to write them natively, that we would write them using some background threads, some low execution background threads. And we decided to take this opportunity to do an experiment and write it using Kotlin multiplatform. It was a huge success. At the end of the project, we did merge that in. And the big benefit here is the code sharing aspect. And I think this runs in the spirit of writing an app in React Native, where one of the goals, of course, is to have it run anywhere: iOS, Android, React Web, React Native Web, and Kotlin multiplatform actually also supports web as well as those other platforms. So great solution. We definitely recommend it. And I don't think we would have been able to enjoy it if we hadn't taken that experiment and taken that plunge. And let's see, you can see some of the stats here where we have a huge amount of code that is shared between iOS and Android, and just a little bit of code that is in those respective platforms, doing things like file I/O, large file download, things that we wanted to write using native code. And of course, you can read the blog post to hear more about this. And I should introduce myself a little bit. So I'm Colin Gray. I'm a principal engineer of mobile at Shopify. And so one of my responsibilities is to identify how we are going to write apps writ large at the company. However, Shopify is a company that values experimentation. We value trying new platforms, new tools, And so we don't want to discourage people from using interesting new technology. Of course, we hope they vet it before. And so that goes contrary to having standards. So a lot of the standards that I'll talk about here are best practice high-level decisions, but not in the details of those decisions. So for instance, when state management would be a good one. I thought that was the next slide, it's not. So let's talk about components. They're, of course, the most important part of React Native. When we write components, we write them so that they can be tested thoroughly, as Gil went over. And what that means is that you, for instance, don't want to be grabbing data from globals, something like new date. That's going to change every time. Let's wrap that in a function that we can easily mock so that we can have consistency there. Another thing that we do is there's a lot of ways to organize your kind of network and data fetching code so that it doesn't interfere with your view code. Container presenter is one. We prefer presenter and hooks, where your hooks are responsible for the network requests, database requests, native module requests, so that the details of those data fetching requirements, that code is not cluttering your view code. It also provides a way that you can have very clear domain objects like view models in other ways. In other words, so yeah, I think that says it all. When we write hooks, do just be careful to. It's easy to plug a lot of functionality into one hook, or it's also easy to have way too many hooks in a component. So finding that balance is another one that we try and be careful with. This next bullet here, be careful with composing generic components. What I mean there is it's easy to feel great about writing composable components, where you might have one that does layout, another that just displays an icon, or maybe a text component that is good at icons and text, and another for just a chevron, or maybe it's able to take any image. What you want to avoid are deep component trees, things that have, your component is at the top, and then you have 10 or 12 components deep after that, a mix of layout and text and images and all that. That really impacts your rendering performance. And so when we see that, we do want to bring those up into a more specialized component that is only 2, 3, 4 levels deep on that component tree. That has a huge impact on performance. Even if you're memoizing components, that initial rendering time will be very large. And also if you consider scrolling behavior, when you're scrolling and you have a deep component tree, there's just no getting around that. It does have to run that rendering code to do a diff on it. And so if it's deeply nested components, that'll take a long time. Another code standard, and this could apply to any software project, is while yes, you do want to keep your code dry, don't repeat yourself, you don't want to go too far with that. If you have two components that are loosely related to each other, but they share a common output, it might be very tempting. So for instance, like an icon and some text to display an avatar and a username or something like that. It would be very tempting to say, oh, we'll make this a generic component. But if the use cases for that component are very different, now you run the risk of kind of conflating those requirements, and a change to one affects another, and you wouldn't have expected that. So this example is a bit contrived, but you can certainly imagine scenarios where because of a shared component and changing the design of that affects the screen that you weren't working on. So don't be afraid to copy in a component that does the job you need it to, or copy a hook that does the job you need it to, and fix it to your requirements. Another easy solve there is to wrap it in another hook, even if it does very little. It might be repetitive, it might not be required, but it at least says, this is how I need this hook to behave, and I'm going to use this shared thing, but if this changes, I can easily swap it out and not have to affect the rest of my code. So Dan Abramov has a great presentation about this. If you Google the wet code base, you'll find this presentation very easily. So Don't need to go too much further with native modules. I think Michelle did a great job there. I do want to point out some cons, though. The maintenance aspect and the domain knowledge, because now you need developers that know Kotlin or know Swift or know both or know about Kotlin multiplatform. And so that certainly adds to the requirement of your mobile developers. One way to ameliorate this is to limit your native modules to very specific problems. Don't have an all-encompassing native module where you're just stuffing any kind of native feature. Try and box them to specific libraries that do a specific task. So for instance, our example earlier, this native sync module that just did one thing. And that way you're not writing views using native code when really you should be using React Native to do those. And you're not just kind of throwing native module solutions when a React Native solution would actually be completely acceptable. Shopify, the standard is, if we can write it in React Native, we do, until that performance or difficulty in writing that code becomes too much, and we'd have to make that call, of course. So in the case of native sync, it was a performance issue. We needed to run it in the background, so we had to reach for a native module there. So here's something I was going to mention that I touched on before. We don't have one state management tool that we prescribe. In point of sale app that I'm working along with Gil and Michelle, we use Redux, but other apps can use other tools. We don't just choose one. The important thing, though, is that all the components, all the developers, all are on board with that decision. And this was something that we had to, a pain point that we had to get past, where we had some screens that were using Redux and other screens that were using nothing or were reaching for a different tool. And so we had to normalize the app at one point. So using one state management tool has a great benefit. Well, some things here: avoiding re-renders. Redux and MobX and other state management tools are all very good at minimizing renders due to state changes, as long as you respect that the scope. So you want your selectors to return very specific data, and then in your components, you want to use those very specific selectors. If you return, or if you fetch high up in that state graph, if you just say, give me everything related to users, then any user change will, of course, result in a re-render. It sounds obvious, but this is one that we had to fix over and over again. So do be careful there. Using one state management tool has big wins on, of course, maintainability. Everyone can step into a component and know what to expect in terms of this very important tool. And then also testability. All these tools have testing in mind, and so they allow you to easily drop in a different state, and make those things. The use of a high-level state management tool doesn't preclude the use of other hooks like use state and use context. You should still reach for those. And also, they don't preclude the use of especially in the case of local state. So you don't want to be putting like checkbox state in Redux. For that, use state is appropriate. So if something is very specific to a component, or vice versa, if something like session has a kind of global context, then put that in a context. So just because you're using global state management doesn't mean you should use that for everything. Sources of truth is, there's a few places to do it and treat all of them important. And my first bullet point here is pour code as a virus. So inevitably what happens, someone has a new feature, they will think of another feature of the app, they'll go to that and they'll copy and paste that component or that hook as a starting point. I highly encourage that. Whatever that code is, if it's been reviewed and tested, then it's probably in a good state. But if it's not, if you have let certain components become kind of out of date with your state management tool selection or your standards on how you organize your hooks, or whether or not you're using the data source class, or whatever standards you've set for that app, if you have a part that has gone stale, someone's going to go in, someone's going to copy it, and they're going to continue those old or poor code decisions. So take the time to make sure that all of your app is written consistently and written to your standards. And if this means that you need to pause feature development, then I hope that you do fight for that. And that's certainly a fight that we had to do in point of sale at one point, and we won that fight. It was the right decision to do, and now we have a better code base for it. Storybook is a great place to have your UI described to developers. It shows in code how to use a component, and it shows visually to designers and to developers how it is expected to look. So we use Storybook for screens, to compose entire screens. We use it for components and for everything in between. Your tests are a great form of documentation. They certainly set in stone how something is supposed to be used, and you should keep that in mind when you're writing the test, that you can have guards around it to say it shouldn't expect this type of input, for instance, so that you can define how it's supposed to be used. If you don't do that, and you run the risk of a function being used how it wasn't intended. And that also goes for documentation. So I'll touch back on that. Comments, this is just a little pet peeve of mine. You often see comments that say this, well here, checks user permissions. Yes, I can see that in the code. Do answer the question of why is code written a certain way? So if user permissions might have changed, then say, make note of that. This is why I'm checking it again. Also, if you ever pull up code, especially your own code, and you don't quite remember why it's doing a certain thing, find out and add that and answer the question why. And lastly, documentation is documentation. Documentation has a risk of getting stale. However, it is also something you can use to set in stone, just like tests, the inputs and outputs and expectations and surface area of a function or a feature. So for instance, if you've got a pagination hook and it is meant to be used a certain way, you don't want people to start tacking on lots and lots of features to explode the functionality of that hook. So the documentation there can actually kind of put the rails on that feature. Also, once a feature is done, especially a high-level feature, native modules, any native module, once it's done or once it's almost done, go ahead and write documentation around it on how it works at a high level. You don't have to write an API. Of course, you can auto-gen your APIs, but yeah, and I think that applies to reusable hooks as well. And then also, if you can have a docs folder with certain patterns, like why you are using data source classes. You might, in our case, we have remote and local data sources, and so we document how and why we have all these different data sources available. So that's a whirlwind tour of how we write React Native apps at Shopify. Thanks for joining us.
Thank you, all of you, for coming here. Please turn on your cameras. This is the time when we get to see everyone's face all together. So, okay, we got 20 minutes. Get your questions into the chat, and we're going to power through these. Starting with the first one. Have you folks been able to run automated UI tests with Storybook like Chromatic does on the web?
I can take that one. So we've been experimenting with some tools to make that possible. We haven't actually decided on one yet. I know there is a tool, I think it's called, I can't remember the actual name, but it runs on top of Storybook, but we haven't actually tested that on React Native yet. But we are exploring on building something new to make that happen. So more news on that soon.
Oh, interesting. Fun little drops for people. Okay, let's move on to the next question. Do you use something on top of Storybook to check if there are any regressions?
Yeah, I think that comes back to the same principle. We are, while we do trust that we have enough people interacting with those components that we will notice any major regressions right away, we are investing on making sure we have an automated tooling as well.
Cool.
Yeah, one additional thing to sort of mention there as well is we like to make everyone really takes ownership of what we're building as well. We have our tooling system has nightly builds that pushes out new versions of the app based on what's been worked on that day. So the whole team installs like the latest version of the nightly builds every morning. So team-wide, we're doing these daily tests as well, and very quickly are able to notice any regressions, especially on the shop team side. Like we haven't even needed to have something like regression testing on Storybook, just because we have so many developers and product folks and designers helping and collaborating to make sure that the quality is always up to the bar.
Great. Okay, our next question. So they're asking, so us at Shopify, are we managing our own packages internally for the React Native modules if the open source packages are too bloated? Who wants to go there? Michelle, I see you're moving up to the mic. Take that.
Yeah. So we do manage them. If we decide not to use an open source package, it's our responsibility to ensure that the what we implement in our app will pass in production and won't cause any crashes, right? So that's where we also have the benefit of the mobile native developers that are at Shopify to ensure that we follow these best practices as we write these native modules.
Awesome. Okay, next question. Why React testing over RTL?
I knew we would get that. There's a couple of reasons, actually. One is that our own library allows us to build things that are more aligned with Shopify core principles. And there's also the fact that we're actually using the same library that allows React for web to be tested. So we're basically in compliance with the pre-existing team, and we're building things on top of the previous learnings. So we're taking everything that the web team has learned across multiple years, and we're applying those principles to React Native as well.
Awesome. Okay, and again, our next question is, what do we mean by presenter? Is it like a container / presenter or a smart / dumb pattern?
Yes, is the answer to that. So in container presenter, you have the presenter only has view code. It is not doing any fetching. Its inputs are very well defined, and I would say especially in native development in iOS and Android, that pattern holds, I think, very well. Like it's a very good fit. In React Native, you end up with a component that is doing component things, handing off to another component, and it's harder to kind of define or to enforce that one should only have the kind of inputs and outputs via props, and the other is allowed to do more things. So instead, we have presenter being just one component, and the container are the hooks logic at the top of it. So at the bottom, you've got just this kind of simple output, but the body of the component are not okay. Here's the caveat is that you can't have this like page and page and page of hooks going on. You need to keep that very manageable. It should be, in my opinion, about a page, no more than a page of like data fetching and things like that. So container presenter now becomes a top of the screen, bottom of the screen, top of the fold, bottom of the fold. It's all kind of in one place. And so that has a huge benefit. The idea of container presenter is still there, though, that you have one aspect that is responsible for the data fetching, external sources, whatever, getting things out of React navigation, like whatever data you need to gather, that's in one place. And then all of the output is handled separate from that.
Awesome, thank you. Next question is, how did we manage the transition of native mobile devs that have no background in React Native? Also, I suppose nowadays all your mobile engineers are expected to know, or at least the basics of React Native. Probably can dispel some rumors there.
Sure. Well, I can say something, though I'd like to hear from Michelle as well. Michelle and I both come from native backgrounds. So Michelle more from Android, myself more from iOS, though I think we've both done both platforms as well. So we have actually individually already taken that journey of going from being a Android or iOS engineer and moving into React Native. In my case, that was something I decided to do. I decided that it was a better platform for my own purposes, and came to Shopify with that experience. For Shopify engineers who didn't make that decision on their own, it was a contentious decision to go all in on React Native. And so we spent quite a bit of time kind of selling that decision. The Shop app, I think, is a great one. It was a big success. Development velocity was very high, and people saw that. Also, it provides something that native development doesn't, which is that we now have the same seat at the table, the React table, that our web front-end developers have. And so there's kind of this no longer blessed group of front-end developers. We're all speaking that same language, and so we can share ideas better. So that's how we sold it. And then we had very specific onboarding classes or programs that we use. And actually, some of the people in this presentation were part of that onboarding. And so, yeah, we didn't just say, go learn it and come back. We actually walked people through that early learning. And so, yeah, Michelle, anything to add or get?
Yeah, I want to add that Shopify has many developers from like all kinds of backgrounds of web and like mobile that where they have they'll be able to help you if you're struggling through the native part of a React Native app. You can go to them for help, or if you're struggling through the web part of it, you can ask the other developers. And that's the benefit of having your team just compiled of all these different people with different backgrounds. The expectation is that you are willing to learn React Native, right? And that's how you become a successful developer, just the willingness to learn something and follow it through. And then, even if you have to pivot, that might happen, that might not, but just that willingness to learn is, I would say that's expected.
Yeah, I think it's incredibly challenging to learn something that you don't have a lot of mentorship and support for, but that's very much not the case at Shopify. There's so many resources, so much mentorship opportunity available, so many pairing opportunities available as well for anything and everything, whether or not we work on the same project or not. And I think that continuously helps like level up everyone at Shopify's like React Native understanding as a company, rather than just like individual people trying to figure it out by themselves.
This is a place that learning is important, and we're all here to help level each other up. It's not about ego. Anyways, I'll move on to the next question. What is a good balance between design system and avoiding composing generic components?
I could take a stab at this one. So the restyle library in particular really helps with this. What it allows you to do is not have to worry about creating a ton of super dumbed down generic components over and over again that all do something similar but are slightly different enough that ends up resulting in, just hundreds of almost duplicate components. The restyle library, for example, allows you to define a starting view component and a text component that accommodates a variety of different style props. So things like margins and paddings and borders and shadows and stuff for box components, and typography specific things for the text component. You can also define a set of variants for your restyle components. So what that allows you to do is just continuously just use the view and text components to create your containers and text elements, but then utilize your theme and your variant definitions and your palette to define how it's going to behave and how it's going to be visualized. That really alleviates the pressure of having to create tons and tons of components, and rather we end up spending time just building the slightly more complex components, or the ones that are reused in a number of different spots, and just use the core features that the restyle library provides on like one-off scenarios or relatively super simple components as well.
Awesome, thank you. Next question. What is a hook that returns view models? I think this is like probably specific to a slide that happened.
Sure. So a good example of that would be, so instead of having a component, let's say you have a component that is doing an orders list. You could just, you start doing your work, you start with a bare component and you do a little bit of kind of maybe dummy code in there, you get a flat list and do a few dummy elements and you say, okay, well, I need to actually do a network request. So you grab Apollo and you put in use query and you get your Apollo results and you display them. That is not very scalable. It is testable because you're going to mock your GraphQL response, but any change to that query, TypeScript will pick up on it, but it becomes more onerous to share that query across multiple screens. and you're not doing a great job of showing your intent for this code. This is arguable, and I think with any kind of contrived example, it's not going to really show it, but it is a small cost to pay to say, take that orders list and put that network code into a hook. Now what you're returning from there should be view models that are specific to kind of the combination of the output of that hook and the components that are consuming it. Some things you get now are if someone has almost the same use case but not quite, when they look at the output of your hook and see that it's actually this specific view model, they might decide, I can't use that hook because it has a very specific purpose and it doesn't match the shape of my requirements. That's a good thing. And this is a case of that kind of dry code base. They should make a new hook. They can copy your query and now they can make changes to it and have it fit the shape of their requirements. Maybe there is a refactoring opportunity there where you can actually reuse it. Great. I'm not saying you shouldn't do that. But when you have a tighter contract between two objects, like a hook and a component, that also informs other developers that breaking this contract is going to break this code over here. The one assumption here is that you're using TypeScript that can kind of inform those connections. But that's, I think, the spirit of it. I could go further. So for instance, if later you decide that you're going to have a database-backed orders list, and now you need a switch to say, well, sometimes I get it from the database, sometimes I get it from the network. That's a lot of code that you don't need cluttering that component. And in fact, with going back to what I spoke of earlier, you want that component to be relatively simple. Fetch a list of orders is a very good hook. The logic of the kind of business logic of fetching a list of orders could get very complicated. So that's where using a hook and using view models is very useful.
Great, thank you. Next question. There's kind of two questions here that kind of go around state management. So I will just say them both at the same time. First is, how does Shopify handle state management, which I think came up a bit. They're asking whether we use the context API or Redux or something else. That's the first question. And the second question is very similar, is like asking if we use Redux, RTK/rematch, or Apollo state management, or context API like the last one.
I'll say a quick answer. I'd love to hear kind of from around the room. We do use context API for sure. It's way too useful not to. We use Redux in point of sale, and Redux kind of out of the box doesn't want you to put complex objects into it, things with functions and whatnot. And so that's one place where using a context can be useful. But also just conceptually, so I mentioned earlier putting like a session into the context. I think conceptually that makes a lot of sense. We are not persisting our Redux store, and so for that reason alone, putting the session in there doesn't make sense. We take it out of secure storage and then drop it into the context at a high level. So it's not a panacea of solution. You need to decide what goes in Redux state, what goes in the context, and then what goes into local component state. So I mentioned earlier, like a checkbox or a form validation. Those are things that are appropriate to a component level state. Use state being the hook of choice. We tend not to use reducer because use reducer is so very Redux-like that we're kind of conflating two things. I think if someone made a good argument for it, I would say, okay, it's appropriate here, but that would be a tough one to convince me of. I think use state can accomplish most of those. And if someone points out that use state is wrapping use reducer, then hats off. That is true, but that's not what I mean. So yeah, does anyone else here have an opinion on that?
Yeah, so on the shop side, the shop app itself doesn't, we explored a number of these different options and we realized that all of them were, like, for example, Redux and MobX and all of those were complete overkill for what we needed. So we actually just used the context API, and that's been more than sufficient for our needs. So I don't mean to make a pun, but like the context in which you're trying to figure out state management is very important. And I know certain apps at Shopify that use Apollo State Management, a couple that use Redux, some that use none, some that just use the context API. So it's very dependent on the situation.
Yeah, I'd like to also add to that because I think using Redux, I've got a bunch of raised eyebrows where when I said that we use Redux and context API, because I think like some people are surprised by that fact, but I think it's important to notice that using both of them actually allows you to separate the concerns and use the context API if only a set of screens or a set of components need that shared information, and it allows you to unmount that if you need to. So whereas like in Redux, you basically have the same store persisted throughout the session, for a context API, you can actually unmount that group of components. So you basically thrown out that information. So it saves also some memory. So I think there's use for all of those.
Awesome. Thank you for that. Okay. We're technically 2 minutes away from this being over, but there are a lot of questions left. And I'm wondering, do you people have meetings? There's like a ton of people who want to know from you, and I'm thinking we can take another 10, 15 minutes to get through these questions. How's that?
Yeah,
everyone on board? Cool. This is a first here for ShipIt. We are going past the time because of the demand. Thank you all for being here and asking such great questions. So let's continue. Can we use JUnit tests to test our code?
Absolutely. So JUnit testing being like something specific to Android. In the Kotlin multiplatform project that we talked about, we call it native sync. Hopefully you caught that. So in native sync, we have the whole project is written in Kotlin, and that has its own suite of tests. Most of them are common tests, meaning they run on Android and iOS. We also have tests that only run on Android, and that's because we have file I/O or network things that we need to test only for Android. And yeah, we use JUnit. We use a JUnit test runner for those. And then we have other tests that only run on iOS. In that case, we don't reach for the Xcode testing suite. We use the Kotlin multi-platform testing tools. It just keeps it all in one code base. They're written in Kotlin, and it just wasn't necessary to reach for the Xcode testing tools. But yeah, you should definitely use the... Now, if you're writing JUnit tests and you don't have native modules, I don't know what you're doing. So I'm not saying, yeah, sure, use it for whatever. No, use it to test those native modules. And and actually the opposite would be, I think, impossible. Like Gil mentioned, you can't use Jest to test those native modules. So, yeah.
Yeah. So for the internally created SDKs that we have, like the checkout on hardware, we have those unit tests for the native portions of it because we still want to catch those as we're creating code in the native side. We have those tests to catch anything that could come up.
Where the next question is asking if we have any experience with React Native Web.
At Shopify, yes, we do. For our two particular projects, no, they're very mobile dependent. But I know the Ping team at Shopify has done lots of experimentation with React Native Web, and the Ping web app is built with React Native Web. So lots of positive outcomes so far already.
Yeah, they did. In their presentation of it, they loved it. The development was very easy. They kind of got support for free. So lots of successes there.
Awesome. Okay, the next question is, do we share JS code with other Shopify applications?
Absolutely. Yeah, we have tons of reusable libraries, restyle being one of those. We have like tons of shared code amongst web and React Native projects and amongst React Native projects as well. So a good example for that is our performance library that we've written to assess the React Native performance. That is basically used across Shopify for all the React Native projects. So it's a good example of that. So I would say definitely.
Yeah, I don't know if that question is getting at this, but some companies are exploring a solution where you have you actually have a tree of components that can run on React and React Native. And while I think that's a very cool idea, and generally what you have is this kind of abstract component tree, and then at the leaves of that you have React or React Native components. I find that it's also very brittle. So that is not something that we have done at Shopify to date. We might change our mind for a specific project, but so far our use cases have been, this is a mobile project, it's React Native. This is a web project, it uses React. And the places that we overlap are in the kind of developer tools like testing, performance maybe, that kind of thing.
Awesome. Okay, next question. Which tools do we use to test performance of components and views or / views?
Sure, I can take this. So a great one is the flame chart of, you start recording, render a component, record the flame chart, and it'll give you a very beautiful visual representation. I keep doing this with my hands when I talk about component depth, and I'm talking about the flame graph when I do that.
That's from React Dev tool, just to make sure.
Right, thank you. And of course, we use Flipper to access that. So that's a big one for me. And then Gil mentioned the AppDex, the React Native performance tool that we use that was built in-house, and that measures initial mounting time, and then it also measures the time to interaction. So that would be after network requests have all resolved and the component is actually usable. So those two numbers are both very useful.
When we're writing a React Native app, can we use TypeScript in the early stages or later?
Yes, like always, you can start right off the bat, or you can start to introduce a TypeScript at a later time if your app previously didn't. That's one of the awesome things about TypeScript, that you can begin to introduce it at any point in time. The more that your app uses TypeScript, though, the better TypeScript's return of investment becomes. And having your app be fully TypeScript scripted just makes it even better to use.
Yeah,
awesome.
we require and use TypeScript on all projects at Shopify, and I am very happy about the decision. I would recommend to anyone at any company. And the idea to me of a project being too small is you shouldn't make fun of your app that might one day be very big. Like, no, start early. Get TypeScript in there. You'll be very happy later on.
Next question. What JS engine are we using? JSC, Hermes, V8? What influenced this choice? And they're thinking particularly about like initial load time, execution speed, overall memory usage, etc.
Yep, we are using Hermes. We love it. We only have it enabled for Android at the moment. The iOS support is, we already have an iOS point of sale app. And so there's not a fire there to build it. We already have a great project there, and that's an iOS native app written with Swift. So there is a long-term plan to replace it, but we have the time to do that properly. We have the time to do that. So we focused on Android. At that time, though, we will absolutely enable Hermes. I think there are a few little edge cases where using JSC would be better, but they're not worth it. Hermes is a great engine, in particular for startup time. So early on, and actually this was in my early days of joining the project, we enabled Hermes and noticed immediately, I don't have percentage numbers on hand, and I don't know if I could find them. I know they were there, but I don't know where they'd be. The startup time decreased significantly, and we were very happy about that. So it was kind of like an easy win. We did it and haven't looked back.
Awesome. Okay, going back to design systems, do we have an open source repository for web where you're able to somehow reuse parts of it in React Native?
So yeah, Polaris has, the Polaris design system has a library available with a bunch of React components for you to use and build UIs with. This is something that we use across the board on a majority of merchant-facing apps and services and whatnot. On the React Native side, we currently don't, and that was not because we didn't want to, but because we didn't really need to. Shop, for example, is the first buyer-facing app that Shopify has ventured into, and the design language is extremely different from Polaris. The value didn't exist there. And for point of sale, their flavor of point of sale is also very different, so they also didn't really need to utilize those same component types, but it was heavily influenced off of the current Polaris system. So currently we have our own individual design systems, and as these projects grow and as other new ones get introduced within Shopify, if there is a need for those to be used across the board, then that would probably happen. One of the other reasons why the Polaris design system is open source and available for other folks is because of our partner ecosystem, where partners can develop apps for the Shopify, for Shopify admin and Shopify apps in general that also adhere to that same UI and aesthetic and design system, whereas we don't have that need on the React Native side just yet.
Okay, next question. This person's asking, they're not an expert in React Native, hence why they're here learning with us. But is it possible to do something like CSS in JS, for example, styled dash components?
Yeah, absolutely. So CSS and JS is the only way actually to do styling in React Native. Given that there's no DOM, there's no official support for anything like CSS or anything like that. So CSS and JS is the default way to go by using the style sheet API that comes along with React Native. There's a number of other open source projects that sort of replace that default functionality. There is actually style components support for React Native. Restyle takes a very different approach to this as well. 100% yes, and I'd recommend checking a bunch of those out to see which one suits your needs.
Great, thank you. Next question. Are all app updates done exclusively through their respective app stores, or does Shopify have the capability to push OTA updates similar to Expo?
I don't know of any apps that are doing over-the-air updates. We just do the traditional App Store approach. I know we explored it for a bit, and it ultimately, the sauce wasn't worth the squeeze on the kind of technology front, if I remember correctly. Does anyone else here have more details there?
Yeah, I think you're right. I think we, especially on the shop side, we have like a very specific and enforced release cycle process, and which has QA built into it, and nightly testing and release testing and all that sort of stuff. So the value to completely change all of that for potential over-the-air updates just didn't suit our needs. So it wasn't something that we ended up needing or explored.
Awesome, thank you. Now our next question is asking if we still have a top hatting process. It wasn't mentioned during the presentation, so they're curious.
Yeah, we sure do. Does anyone else want to jump on that?
Sure. So Expo, for example, has this QR code scanning capabilities where you can just scan a QR code and have that app or a version of that app built to your device. So we love that feature so much that some folks in-house actually recreated that and rebuilt that functionality for React Native projects that don't utilize Expo. And so this is something that we've built and utilized internally. So anytime we create a new pull request, a QR code gets automatically generated for that pull request in particular that we can then scan and top hat that particular PR. That works fantastic for developers trying to do top hatting for each other, and also for non-developers to also participate in the top hatting experience as well. We use that same concept for building snapshots for specific pull requests and nightly builds as well. And that's sort of like how we're able to rapidly distribute various versions or iterations of our apps for other team members to test out.
Awesome. I just dropped, sorry. Go ahead.
I'll add just a little bit to that, which is that, so at Shopify, the process is that our developers do QA, but not just yourself on your own PR. I think the crucial thing is that you need to find other developers to also do QA on your PR. That brings some more honesty to your PR. It needs to be of a quality that is immediately testable and runnable and doesn't have any glitches or thing you need to get set up. So it keeps people a little more honest on high quality pull requests. And so, yeah, part of our top hatting process is to make sure that we do good code reviews.
Awesome. I dropped a link about our top hatting in React Native process from the engineering blog because we talked about that. So take a look. I unfortunately have to cut us short. We could be here forever because you guys are amazing. You have so many questions. What we're going to do is take these questions away and make sure to get them up on the engineering blog for you. So they will be answered, even though we're not answering them live. Thank you all for joining us. And Gil, Harris, Michelle, Colin, thank you so much for being here and taking the gauntlet of questions from our awesome audience today. Really engaging. And thank you all for showing up and staying with us past the normal time. I will be sending out a video link to this to everyone who registered. It'll also go up on Twitter and through our newsletter. So sign up for those things if you aren't already following us. Again, Shopify is hiring 2021 engineers in 2021. So take a look at that Shopify engineer or Shopify careers page and look for the job for you. Please come back and join us on June 30th because it's a special ShipIt where we're bringing our friends from Let's Encrypt here, and we're going to talk about our commitment to creating a secure and privacy-respecting web. Follow us on Twitter for when that sign up goes out. Also get on our newsletter for that also. Thank you all for being here. Thank you to our guests, and I hope you all have a really great rest of your day. Bye.